Good afternoon, everyone. This afternoon, we will dive into discovering of the sky, altitude, and azimuth. This afternoon, let's take a closer look on how altitude and azimuth help us explore the sky. Imagine using these coordinates like a map to find your way among the stars and planets. Together, we'll unravel the mystery of celestial navigation and learn how altitude and azimuth guide us through the wonders of the night sky. Welcome to a captivating exploration of altitude and azimuth, where the sky is not the limit but the beginning of an extraordinary adventure.
Good day, everyone. So, the title of our lesson today is Altitude and Azimuth. So, our objective this afternoon are students will learn what altitude and azimuth are and how they help locate objects in the sky. Students will be able to use basic tools to measure the angle above the horizon and the direction of celestial objects. And last, students will value the practical skills gained through understanding and applying altitude and azimuth measurement in astronomy and navigation. So next slide, we have our definition of terms to found.
So we begin. The night has long fascinated people everywhere. So here we have the altitude and azimuth or horizon coordinate system. First is horizon. Horizon is the line where the sky meets the ground. This is sometimes hard to find if there are interesting mountains or trees in the way. But if you go someplace with nothing interesting to see, like the middle of the ocean or field, you can easily see the horizon. Next, the zenith. The zenith is the point direction over your head. Look up, yes, that's right. That is the zenith. The angle between the zenith and the horizon through your body is 90 degrees. Kung nakasulod sa inyong balay, ayaw na laghangad. Lisod po. This is best in open field. Next is our main focus this afternoon, which is the altitude and azimuth. Altitude, the height of an object above the horizon, measured in degrees. An object on the horizon has 0 degrees altitude. An object at the zenith has 90-degree altitude. An object halfway in between is at 45 degrees altitude. But this coordinate is not enough. You also need to know the direction. Of course, the north, south, east, and the west. Next is azimuth. The azimuth tells you how far around the object is from the north. It is also measured in degrees and start at 0 degrees north. Due east is 90 degrees azimuth, due south is 180, and due west is 270 degrees. So now you can indicate a place in the sky with remarkable precision. But the location of an object in the sky depends on your location on the planet and the time of your observation. Think of a sun, which is in different places in the sky at different times and from different location. So the horizon coordinate system is not ideal for astronomical purposes, since an astronomer will have to keep changing their notes depending on the time of day or their location. Note you can actually use this to your advantage if you have a clock. You can find out exact location of a star using a compass and a sextant. And the topic will be covered and discussed by the next reporter, Ms. Rachel.
Altitude and azimuth. Altitude refers to the angle of an astronomical object above the horizon. It is measured in degrees from 0 degrees at the horizon to 90 degrees at the zenith directly overhead. It is varies based on the observer's location and time, as celestial objects rise and set, making it essential for accurately locating and tracking them in the sky. This understanding is crucial for celestial navigation and observation astronomy, allowing astronomers and stargazers to determine the position of stars and other objects effectively. For example, if a star is halfway up in the sky, its altitude would be 45 degrees. And the other coordinate is the azimuth. It indicates direction along the horizon with 0 degree as north and 90 degree as east. Why measuring altitude and azimuth in astronomy is essential for locating celestial objects in the sky. So when we measure the altitude and azimuth, we will use a two instrument, and it is a sextant and a compass. Mm, When we measure altitude, like we say before, the altitude is the angle between a celestial objects and the observer's local horizon. It ranges from 0 degrees at the horizon and 90 degrees directly overhead. So we can we can measure this by using the instrument sextant for precise angle and measurements. In measuring azimuth, we said before that azimuth is the horizontal angle measured clockwise from true north, ranging from 0 degrees to 360 degrees. So when we measure azimuth, we use the instrument's compass to find direction or accurate measurements. Azimuth is crucial component of altitude azimuth coordinate system, which astronomers use to locate celestial objects in the sky. Azimuth specially refers to the horizontal angle, like we said before, and measured clockwise from true north from values ranging from 0 degrees to 360 degrees. So there are five key aspects for azimuth in astronomy. First is coordinate system. In the altitude azimuth system, azimuth complement altitude, which measures how high an object is above the horizon. This system is observed specific, meaning that azimuth changes based on the observer's location and the time of observation. The second key aspect of azimuth is the direction, where azimuth helps astronomers specify the direction in which to look for essential objects. For instance, an object with an azimuth of 90 degrees would be found due east, while an object at 270 degrees would be due west. West, I mean. So for the third key aspect is the finding celestial objects. It is to locate a star or planet. Astronomers typically provide its altitude and azimuth coordinates. So for example, if a star is at an altitude of 45 degree and an azimuth is 150 degree, you would look um, 45 degree above the horizon toward to the southeast to find it. The fourth key aspect is the tracking motion. Whereas the Earth rotates, the azimuth and celestial objects changes over time. This motion is important for tracking the movement of the stars, planets, and satellites across the sky, allowing astronomers to make observation at specific times. So the last key aspect of azimuth is the tools for measurement. Um, I mentioned earlier that azimuth can be measured in compass. Compass. It is the most um, used instrument to measure the azimuth, and it is the compass. So, in summary, azimuth is a vital concept in astronomy that allow astronomers and enthusiasts to effectively locate and observe celestial phenomena and the night sky.
So, practical use of altitude and azimuth. Now, altitude and azimuth are angular measurements used in astronomy and navigation to specify the position of an object in the sky. So, here are some of the practical uses of altitude and azimuth. First, we have here the astronomy observations, locating celestial objects. So, amateur astronomers and professionals use altitude or the angle above the horizon and azimuth, which is the angle from the north, to locate stars, planets, and other celestial phenomena. So, telescopes and stars charts are often used these coordinates for guidance. Aside from that, many astronomy apps can provide real-time information about the altitude and azimuth of celestial objects based on the user's location. So, in the field of astronomy, accurately locating the celestial objects is crucial for both amateur and professional astronomers. Therefore, kana siya nga process heavily relies jud siya together sa concepts of altitude and azimuth. Together, because both um, they coordinate system, they're a coordinate system analogous to latitude and longitude on Earth. So, we have to understand, no, because understanding these concepts enables astronomers to pinpoint the position of the celestial bodies in the sky relative to the observer's location on Earth. So, altitude and azimuth system provides a local coordinate framework, meaning ang coordinates kay nakaspecify, specific siya sa observer's location and time. So, as the Earth rotates, because usually mo rotate man gyud, diba? As the Earth rotates, and apparent positions of celestial objects kay ma-change pod, meaning ang celestial objects altitude and azimuth will change throughout the night or over the course of year. Na-explain naman og ayo from the previous reporters, right? Kung unsaon or giunsa pag-measure, di ba? So, para malocate ang celestial objects using altitude and azimuth. So, for example, ikaw or tayo yung observer, okay? Then, you wishes to find the planet Mars at an altitude of 45 degree and an azimuth of 120. So, you face towards saan tayo mag-face? Toward the southeast, because that's the 120 degree azimuth. And then you look up at the angle, di ba, you face the southeast, and then you look up at the angle of 45 degree above the horizon. This method is straightforward for locating stars, planets, comets, and other celestial bodies. So it's already been explained, so let's not dive too much on that, no, because although understanding this system not only enhances our ability to navigate the heavens, but it deepens also our appreciation for the intricate movements of celestial bodies, allowing more individual to connect with the cosmos. Okay. Now we have satellite tracking. The satellites in low Earth orbit or LEO can be tracked using altitude and azimuth coordinates. So observers can determine when a satellite will be visible and where to point their equipment. So naka-mention tag LEO, right? Kining low Earth orbit refers ni siya sa region of space above the earth surface. We forgot about that. Typically between 180 kilometers, and if we convert that into miles, that's 112 miles, and 2,000 kilometers. If we convert that again into miles, that's 1,242 miles in altitude. So, satellites in LEO travels at high speed, often completing an orbit in about 90 to 120 minutes. So, satellites in this orbit are used for a range of services including Earth observation, telecommunication, and scientific research due to their close proximity to the Earth. Actually, na mga certain times nga visible ang satellite, depende po na siya sa location, no? Specific location depending on their orbit and the position of the sun. The ability to track a satellite trajectory helps in predicting these visibility windows, no? Or when the satellites reflect sunlight, making them visible against the against the dark backdrops of space. It's amazing actually, especially shortly after sunset or before sunrise. Kung giunsa nila to siya pag calculate with the, of course with the help of azimuth and altitude. And naa sila ginatawag nga TLE, that means two line element. It is to track satellites and observers were typically use a set of orbital parameters called TLS. Okay, so these parameters provide data about the satellite's position, velocity, and orbit around time. And then one thing, they have what they call predictive models. So software and mobiles application leverage the TLS to calculate the altitude and azimuth of satellite in any given time, allowing users to see when and where a satellite will be visible in their local sky. Mostly na look that kind of phenomenon ng malocate nila ang satellite na nag-orbit siya sa ato ang Earth is. Mostly na siya sa mga America, those ports. Okay. Now we have the navigation. So, maritime navigation. Sailors use altitude and azimuth for celestial navigation, locating their position at sea by measuring the altitude of stars and using azimuth to determine the direction of travel. Diba? The navigation, something like that. So it's very useful. So in maritime navigation, particularly in the practice of celestial navigation, the altitude and azimuth, these measurements assist sailors in determining their position at sea and guiding their course toward a destination. So unsa na mga measurement techniques ilang ginabuhat, no, sa measuring altitude, naa sila ginatawag na sextant usage. So where sailors commonly use a sextant, it's an instrument that measures the angles of the celestial body above the horizon. So para ma-obtain ang accurate altitude reading, a sailor sights the celestial body, aligns the horizontal reference with the horizon, and they will adjust the arc until the image of the celestial body coincides with the horizon line. It's actually very amazing. You can search that one if you really want to further understand or know the image of sextant. So, and of course, ang mga times sa pag-measure sa altitude vary throughout the day. And for accuracy, mariners take measurements with specific times. For instance, the sun's highest position in the sky, measured at local noon, is particularly useful. Okay. Now we have aerial navigation. So pilots use these measurements, the altitude and azimuth, to locate flight path and assess their positions relative to landmark or celestial bodies. Nabilong na diha ang mga pag-measure nila para sa, to avoid the turbulence during sa mga flight, and also waypoints kung nakafamiliar mo ana mga like specified coordinates from the tower and to the pilot using azimuth para para makanavigate from their current positions to the next waypoint, meaning adjusting for wind direction and speed to correct their course as needed. So pilots are also adjust altitude based on their air traffic, whether like weather considerations and the flight plan, etc. No, very useful kay ang altitude and azimuth. So next we have map making and surveying. So topographic surveys. Surveyors employ altitude and azimuth when measuring angles to calculate distances and create accurate maps and land surveys. So altitude and azimuth are indispensable measurements in map making and surveying, particularly in creating topographic surveys that accurately depicts land features. So these measurements facilitate the accurate determination of position, position, shape, and elevation of maps, enabling surveyors to provide reliable and precise geographic information. So, understanding and applying these concepts are fundamental to the success of mapping efforts, influencing various applications from urban planning and construction to environmental management and land use. So, through a blend of traditional methods and modern technologies, altitude and azimuth measurements remain integral to the art and science of surveying. So, we have next geolocation. Altitude and azimuth can assist in pinpointing geographic location, especially when combined with GPS technology. So, since we're in the increasing interconnected world, the ability to determine precise location on Earth is paramount for applications in navigation, mapping, and various technological platforms. So, geolocation refers to the identification of the geographic location of an object, person, or device. Two critical measurements in this process are altitude and azimuth again. Um, so, these measurements, particularly when used in conjunction with global positioning system or the GPS technology, provide accurate and reliable data for pinpointing geographic locations. Since altitude and azimuth are crucial for accurate navigation, be it by air or land or sea, as what I've mentioned na, pilots use GPS data, 'di ba? Which includes altitude and azimuth, to chart flight paths and course adjustment based on landmarks, waypoints, and air traffic control instruction. Similarly, sailors rely on these measurements to navigate ship, ships across oceans, ensuring they remain on course in relation to land masses and other navigational aids. Alright, we have mapping and cartography. So, Geographic Information System or GIS integrates altitude and azimuth data to create detailed maps. So, this technology allows users to visualize terrain, plan construction projects, and analyze geographic pattern. For instance, altitude data can represent elevation changes as contour lines, while azimuth dictates the orientation of features on the map. Um, topographic mapping, urban plan, topographic mapping, urban planning. What else? Environmental assessments all benefits from the integration of altitude and azimuth measurements derived from GPS technology. So we have augmented reality or AR and location-based services. So application in augmented reality use altitude and azimuth to enhance user experiences by overlaying digital information and real world views. Uh, AR applications can display contextual information based on the user's precise location and direction. Um, we mentioned location-based services. Example for that is navigation apps, geological surveys. Okay, so um, what did I say kanina? Location-based services utilize altitude and azimuth to provide users with real-time information about their surroundings, such as nearby landmarks, restaurants, or points of interest. So, altitude and azimuth are fundamental measurements in the realm of geolocation, playing a vital role in determining precise location uh, on Earth. Alright? So, their integration with GPS technology enhances the accuracy and reliability of geographic positioning, which is essential siya in various applications, including navigation, mapping, augmented reality, emergency services, and scientific research. So, understanding and applying altitude and azimuth principles contribute to improved geolocation systems and technologies, illustrating their ongoing significance in a rapid advancing world. So moving on, okay, we have solar energy application. Now, solar panel positioning. The optimal placement of solar panel requires knowledge of sun's altitude, which is the height in the sky, and azimuth or the direction. So this helps maximize energy capture throughout the day and year. So basically, solar collectors are positioned to face the sun directly, which may require an adjustable tilt and orientation, like the azimuth, based on daily and seasonal changes in sunlight availability. So the altitude and azimuth are integral measurements in harnessing solar energy efficiently. They inform the orientation of solar panels throughout the day and across seasons, optimizing solar energy captures and enhancing overall performances of solar energy system. So, by understanding and applying these concepts, engineers, designers, and homeowners can significantly increase energy production. Okay, so contributing to a more sustainable energy future through advancements in solar tracking technology and predictive modeling. The effective implementation of altitude and azimuth measurements is essential to a success of solar energy applications in the ever evolving energy landscape. Okay. So, dito naman tayo sa solar farm design. So, engineers use these measurements in the designs and arrangement of solar farms to enhance efficiency. Diba? Para ma-optimize ang position sa solar panel and para ma-maximize ang ginatawag nilang solar radiance capture, engineers leverage the measurements of altitude and azimuth. Ang pag-calculate sa measurements kay parihara pod sa kung giunsa ang solar panel positioning. Itong na-mention ako ganiha. Okay? So, May mga tilt angle, no? Something like that. Since ang pag-angle sa altitude and azimuth sa sun kay directly influence sa orientation and tilt of solar panels. Engineers must determine the optimal tilt angle based on geographic location and seasonal variations. So, naa diha ang katong mga single axis tracking, nadira ang katong mga dual axis tracking, if you're familiar with that, those things that rotates, which follows the sun's path, kato, in both vertical and horizontal directions, kato siya mo to. And of course, those experts in this field gina-analyze sadto nila ilahang datas, mga stimulation software, etc., etc., etc. Now we have architecture and urban planning. So, natural lighting. So, architects may use altitude and azimuth to analyze how sunlight will interact, with the building throughout the day and across seasons, impacting designs for energy efficiency and aesthetics. Alright? So, of course, understanding the concepts of altitude and azimuth is quite crucial for architects and designers as they analyze how sunlight interact with buildings during different times of the day and throughout various seasons. Kung nakatanaw mo atong video bitaw sa una, regarding atong building to siya, and if masindagan og adlaw kay very nice kayo, like very shining, shimmering, and glimmering, like splendid, okay? Very aesthetic, kumbaga. So, although na ay drawbacks sa mga citizens kay silaw daw or whatsoever, dugay na magod to, but it fits perfectly as an example for this natural lighting, no, architecture and urban planning. So, now we moved on. Alright, so wind and weather patterns. So, urban planners can also use these measurements to assess how surrounding building affects wind flow and other environmental factors. Yes, wind direction and speed, weather patterns, etc., etc. Balik na tano, altitude and azimuth are kay vital components jud siya in understanding and predicting wind and weather patterns. So, their influence extends across various disciplines, like enabling more effective planning and management of resources related to weather forecasting, agriculture, urban developments, and environmental protection. By leveraging these measurements, no, scientists or urban planners and architects can make informed decisions and contribute to the sustainability and resilience of community in the face of changing weather conditions. Okay. So now, moving on, we are talking about the military applications, targeting systems. Okay, so in military applications may involve using altitude and azimuth for targeting weapon systems or directing aerial reconnaissance. So, in military application man gid guys, particularly regarding sa targeting systems and aerial reconnaissance, their importance cannot be overstated. Precise understanding and calculations of these factors allow for improved targeting accuracy, enhanced navigational capabilities, and optimized operational effectiveness. Or unsa pa nilang mga tactical trainings or mga ballistic calculations, like no room for errors. Okay, so as military technology continues to advance, the integration of altitude and azimuth data will remain essential for achieving mission objectives and maintaining operational superiority. the ability to accurately assess, no, the ability to accurately assess and employ these measurements can significantly impact strategic outcomes in modern warfare, leading to leading to more effective military operationals overall. Okay, operations overall. Okay. All right. So, um, next to that is the aircraft navigation. 'Di ba? So, military pilots often rely on these angular measurements for traditional navigations as well as in low visibility situations. Kung hilig mo mga RPGs games bitaw, makarelate ra gyapon mo sa mga traditional navigation in terms of aircraft, visual navigations, and dead reckoning. Okay? Parehas akong na-mention na kaganiha with regards sa waypoints na how pilots calculate those something something sa altitude na azimuth. Yes, importante po din siya sa aircraft navigation. Alright, lastly, so the entertainment and virtual reality. So, augmented reality or AR, na-mention natin ni ganina, AR applications can utilize altitude and azimuth to overlay information on users' screens that aligns with real-world celestial objects or landmarks. Diba? And then we have here in our screen is games. So, video games that involve explorations are space themes often use altitude and azimuth to create realistic navigation and positioning within the game's world. In short, mala Sword Art Online ang tiradaan niya, no? Virtual reality, kumbaga ba? Diba? And then, what were the games example, ana? We have the Roblox, the COD, even ang katong ML, no, those games, those interactive stimulating games. Azimuth and altitude, it's also a based example for that. Okay, so now we have next slide for the next reporter.
How altitude and azimuth are used in celestial navigation. So, altitude and azimuth are crucial for celestial navigation, a method of finding one's position on Earth using the position of celestial object. By measuring the altitude and azimuth of a celestial object, navigators can pinpoint their location. This process involves using a sextant to measure the altitude of a celestial object and a compass to determine the azimuth. These measurements are then used in conjunction with astronomical tables or software to calculate the observer's position. The key principle is that the altitude and the azimuth of a celestial object vary depending on the observer's location and the time of observation. So, why is it used in celestial navigation? Ano daw, nigamit ta ning celestial navigation. So, celestial navigation has been a vital tool for seafarers and explorers for centuries. Ginagamit ni sa mga kanang mga seamans or kana bitang magbiyahe or mga explorers. And then, it is particularly valuable in situation where electronic navigation system are unavailable or unreliable, kanang di bitaw walay signal kana ilang gamiton. For example, mawala sila sa isa ka lugar, gamiton nila na in order for them makabalik sa lugar nga ilang adtuan. For example, kanang sa remote areas where GPS signals are weak or non-existent. Tapos ang ikaduha is emergency situation when electronic equipment is nag-fail. Then ang historical context is kanang sabton or masabtan nato or understanding atong masabtan or how we understand people nga nag-navigate before modern technology. So, how do altitude and azimuth coordinates contribute this to the spatial orientation and positional tracking of celestial object in the sky. So the altitude and azimuth coordinates are like a celestial address system, providing a precise way to pinpoint the location of the celestial object in the sky relative to the observer on Earth. So here's how they contribute to spatial orientation and positional tracking. So sa spatial orientation, imagine a vertical line drawn from the observer's eye to the horizon. So the altitude measure the angle between this line and the celestial object. It essentially tells you how high the object is in the sky. So na vertical line nga makitaan or madron sa kita nga mag-observe sa kita nga mag-observe then kanang altitude is ma-measure niya ang angle between sa line sa celestial object and maingon pod nato or maingon sa observer kung unsa kalayo or unsa kataas ang isa ka object nga naa sa langit. So the azimuth, which is picture a compass. So picture a compass. So azimuth measures the angle between north and the projection of the celestial object onto the horizon. It tells you the object direction from north. So ang tabang dahil sa azimuth is makaingon siya kung unsa ang direksyon sa object nga gikan sa north. So together, ang altitude and azimuth maka-create siya og 3D coordinate system nga moallow sa tuwa nga ma-visualize ang isa ka ang position sa isa ka object sa sky. So, imagine a sphere with the observer at the center. Altitude tells you how far up on the sphere the object is, and azimuth tells you its position on the sphere circumference. So kani sa spatial orientation is ang kuan daw ang altitude is mag-ingon sa tuwa kung unsa kataas ang isa ka object nga naa sa sky, then ang sa azimuth pod under sa azimuth is mag-ingon siya kung asa siya nga direction or asa siya nga position. So the second one nga na mention ganina, which is the positional tracking, is under the celestial motion. Celestial object are constantly moving due to the earth rotation and the object's movement or own movement. Altitude and azimuth coordinate change as the objects move. So another one is by tracking by measuring the changing altitude and the azimuth of an object over time. Ang astronomer daw kay matrack nila ang path across the sky, study its motion, then understand its orbital characteristic. For example, ma-determine nila ang kapaspas sa star o ang direction or ang orbital planet's orbital period. So in the essence, ang ultimo azimuth provides a dynamic framework for understanding the position of celestial objects relative to the observer, allowing for the tracking of their movement across the sky. This is crucial for various applications from scientific research to navigation and recreational stargazing. So, example aning kuan paggamit nato sa kuan celestial navigation is example kanang nawala ka sa sea or you are lost at sea. Then imagine a sailboat sailing through the vast Pacific Ocean. Then suddenly na ay ni strike ninyo nga kuan storm, then kanang knocking out the boat's electronic including the GPS. Syempre gi nakuanan mo bagyo, so for sure wala gid may signal, and then the crew is lost with no way to know their position. So unsay solution? Using a sextant and a compass, the crew can measure the altitude and azimuth of a known star by comparing this measurement to star charts or nautical almanacs. They can calculate their latitude and longitude, allowing them to navigate back to safety. So, importante gid siya. So another example po is a group of hikers is deep in a remote wilderness area far from any cell service. So ilang GPS device is nagmalfunction, leaving them with no way to know their exact location. So unsa may solution ani? So using a compass gyapon o star chart, ma-identify nilang recognizable star and ma-measure nila ang altitude o azimuth. By comparing these measurement to the star chart, they can determine their approximate latitude and longitude, helping them find their way back to the trail. So, by using kanang compass o ang star chart kay ma-compare nila or makatabang na siya para makauli sila sa ilahang lugar. So another example is historical exploration, which is a group of archaeologists is exploring a remote island hoping to discover ancient ruins. They know that the island was once inhabited by a seafaring civilization they lack any modern navigation tools. So unsay solusyonan ni by studying historical texts and artifacts, they can learn how the ancient people use celestial navigation. So they can replicate these techniques using a sextance and compass to measure the altitude and azimuth of stars to navigate the island and potentially uncover the lost ruins. So this scenario highlight the importance of celestial navigation in situation where modern technology fails or is unavailable. So magamit na ining celestial navigation if ever nga kanang something happen bitaw, for example kanang nawad-an mong signal or walay signal ana nga lugar, kaning celestial navigation na knowledge nimo is magamit nimo in order for us or for you to come back to asa kagikan in order para makabalik ka sa imuhang kanang gi lugar. So by understanding the relationship between altitude, azimuth, and the position of celestial objects, people can navigate effectively even the most challenging environment. So kana very gamit na ini siya gyud sa ato ang kinabuhi ang celestial navigation. So isa pa is in essence, the altitude and azimuth provide a framework for understanding the position of celestial object relative to the observer, allowing for a calculation of the observer's location on Earth. This makes celestial navigation a valuable tool for various purposes, especially when other navigation systems are unavailable or unreliable. So, kato akong giingon ganina nga, if ever mag-malfunction ang ato ang mga devices, atong mga technologies, pwede ni nato siya magamit ang atong knowledge about celestial navigation. So, why are these coordinate systems crucial for astronomers, navigators, and individuals engaging in activities that require precise location, determination of celestial bodies for navigation or occasional stargazing purposes? So, ang azimuth o altitude coordinates are crucial for astronomers, navigators, and stargazers because they provide a universal language for describing the position of celestial objects. For example, lang sa astronomers is for them is the precise observation. Astronomer needs to know the exact location of celestial object to study their properties, tracking their movements, and understand their interaction. Altitude and azimuth allow them to pinpoint object in the sky with accuracy, enabling detailed observation and analysis. So the second one po nga nung kuan is predicting events, knowing the precise position of celestial objects that allows astronomers to predict events like solar eclipse, lunar eclipse, or occultations and planetary conjunction. This is very crucial for planning observation and understanding the dynamics of the solar system. So sa navigators for them is it is important because it is the way to find our ay parang diri makatabang para makabalik ta sa ato ang lugar pag mawala ta. So celestial navigation using the stars to determine your location relies on altitude and azimuth measurement. Navigator use these coordinates to calculate their latitude and longitude. Essential for navigating across vast distance, especially when navigation systems are unavailable. So, for another one is for navigator ang historical significance pod. So celestial navigation has been used for centuries, allowing explorer and seafarers to chart unknown territories and navigate safely across oceans. Understanding altitude and azimuth is crucial for appreciating the history of navigation and its role in exploration. So the another one is the recreational stargazer. For them, it is important because kaning sa pagpangitaw constellation, altitude and azimuth coordinates help stargazer identify specific stars and constellation in the night sky. Di ba mo ng mga Orion, the Cassiopeia, or mga Taurus, Gemini, kanang mga constellation sa langit mo na. Then, this enhances their stargazing experience, allowing them to locate specific object and learn more about the constellation. So, important po sa ilaha ang planning observation. So, ang mga stargazer can use altitude and azimuth para maplan nila ang ilahang mga observation, knowing when and where specific celestial object will be visible. This allows them to maximize their viewing opportunities and witness celestial events like meteor shower or planetary conjunction, di ba kanang mga kanang usahay kay mag-announce sila nga uy kani makit-an ni siya diri nga orasa kana siya ang hinungdan nganong important kay na siya sa mga stargazer kay aron maibawaan nila kung kano sa mag stargaze kung kano sa ang meteor shower kung kano sa makita ng kani nga star kung kani ba siya nga star is visible ani nga adlaw. So So, in summary, altitude and azimuth provide a common framework for understanding and communicating the position of celestial objects. This makes them essential for astronomers, navigators, and gazer alike, enabling accurate observation, navigation, and a deeper appreciation of the wonders of the night sky. So, summary ani is very crucial or very important ang celestial navigation is because kanang magamit siya sa ato ang mga explorers sa ato ang mga navigators dili lang tungod kay para makabalik sa ilang lugar if ever nga mawala sila sa ma kanang ginatawag nila maligaw sila sa biyahe or whatsoever kanang sa celestial navigations in sa tabang sa azimuth ug altitude is makabalik sila sa ilang lugar and then ang mga stargazers kay mahibal-an nila unsa nga event ang mahitabuan na nga adlaw nga panahona and sa sa explorers is kanang mahibal-an nila kung unsa nga position unsa nga direction unsa kataas ba na nga object nga naa sa langit.
So for our activity, we called it Measure Me. So we have materials needed here in this activity. So first, materials, we have a smartphones or a small magnetic compass. Second is a ruler marked in centimeters. And the third one is a sidewalk chalk. So before the students will do this activity, the students should be able to know how to use the compass. So now let's proceed to the procedure. So first procedure is that using the chalk, mark X to identify 10 different locations where students will stand. Second, students have to stand on a fixed place or where the mark X and hold the compass flat and level in their hands. Third, now turn toward the target. For example, a distant tree or any other object, and adjust the compass so the end lines up with the compass needle. The direction you are looking toward the object shows you are bearing or azimuth direction. The fourth one is that the student stands on the mark and look toward the object they wish to measure. Hold the ruler at arm's length and count how many centimeters tall the object is. It is sometimes useful for students to work in pairs. One student holds the ruler and sights the object while the other runs their fingers slowly up the ruler. When the fingers reaches the top of the object, the observer calls stop and the measurement is read off the ruler.
Now, for the last step, record the measurement on your worksheet.
Okay, so para masabtan no ang video nga gi-demonstrate na mo is this is our further explanation pagyon. So as you can see sa video nga gi-demonstrate is that the first step there is to mark X sa maong bet na object. Next, kay i-locate as sa dapita ang north pointing the object. Third step there is to locate the azimuth. It's too easy to identify the azimuth of an object. Simply move the compass from the north clockwise and that's our azimuth. After identifying how many degree the azimuth is, let's proceed to the altitude. So, in calculating the altitude is that from the mark X, sightan tong object using ruler or anything nga i-point nimo sa mao nga object. And then your pair will measure sa katason sa mao na object in centimeters. So for example, ang katason kay 69 inches man nga dayon i-times dayon nato na siya sa 300 centimeters. Kay ang 300 centimeters kay 12 inches man na siya. So, maong 300 times 69 is equal to 20,700 centimeters and that is our altitude.
So, let's proceed to our wrap-up. So, altitude and azimuth are key angular measurement in astronomy used to identify the position of celestial objects relative to an observer on Earth. Altitude refers to the angle an object makes above the horizon, while azimuth is the angle measured clockwise from true north to the object location in the sky. Altitude can be measured using instruments like sextants or digital altimeters, where the angle between the celestial object and the horizon is determined.
Azimuth is typically measured using a compass indicating the angular direction from north. In astronomy, they allow for precise tracking and observation of celestial bodies by both amateurs and professional astronomers. In navigation, they assist sailors and pilots in orienting themselves using the stars. In surveying, the accurate map creation in military operation for navigation and targeting, and in architecture to enhance natural lighting in buildings. Overall, altitude and azimuth remain essential tools for various practical applications, reflecting their ongoing relevance in both scientific and everyday contexts.